One of the things that we've seen so far is the ability to store small, simple types of data, maybe a string or a number. Well, sometimes we need to store groups of related data or complex sets of data. Now, that was something that many programming languages very early on could not provide for us. However, as computers have gotten more powerful and we expect them to do more things, computer languages have started giving us more and more ways of storing collections of data. We're going to look at one of those collections of data that Python provides for us. Now, Python, when they have a collection of data, they call it a sequence. Now, that's just their name for it, and they have 4 commonly used built-in sequences that we are going to look at. The one that we're going to look at today is called a list. And a list has a lot of similarities with other data structures that are in other languages. Most languages call them an array. So let's take a look at what's going to happen with that. Okay, so here's a variable called sample, and it has a list in it. Now, a list is very simple. You'll notice it's square brackets, and then it's a number, comma, another number, comma, another number, and you can kind of see this list. Each number is referred to as an element of that list. And so if I want to add a new element, all I have to do is come in here, put a comma, and put a value. Now, there's a couple things I want to point out. While I have decided to go up an increasing value, that is not required. I do not have to have my values in a list sorted. Okay? That's completely up to you. In my case, I did it. I don't have to. I do need to have a comma in between each list element. The other thing I do not have to have is I do not have to have all numbers. I could, for example, have a list of strings. So here I've created a list, names, and I have 4 names. Notice there are 4 strings. Each are once again separated by a comma. Well, what's even more interesting is I can mix and match these. Now, many languages in an array, all of your data has to be of the same data type. But because Python handles data typing behind the scenes, we're actually allowed to mix and match data types inside of our list. Here's an example of us mixing and matching data types inside of a list. One of the things that I do want to kind of point out, and I think it's worth mentioning, is you'll see that I have 3 different variables, all that have list. One of these I think is slightly better named than the others. You might go, well, what do you mean slightly better named? Well, one of them in its variable name gives a hint that we're looking at a plurality of data. That is names. And I like to personally, when I'm naming my list variables, I like to give them a plural name so that it provides a hint to me, the developer, that there's more than one element in here. Now, clearly you can see that that's not required. This is just a suggestion based off of years of experience of programming that will make your life a little bit easier. So keep that in mind. You might think, well, how could I give these better names? Well, I could say something like data underscore samples. And now I have a slightly better name. Remember, variable names can be anything that you want to create, but they should be meaningful. And that's a real important thing. Remember that while you have a lot of flexibility with how you name your variables, and you could name them A, B, C, Bob, Fred, Jane, etc., the goal is to make variable names meaningful for you. That way they're easy to remember, they're easy to use. Now, we've actually seen lists before. If you remember when we talked about the for loop, we said the for loop was specifically designed to help us iterate over a sequence of data, usually a list. So let's take a look at that real quick, how that would work. Say for, I'm going to say name in names. So notice I have a singular variable name, name, and I have the plural, which is my list of names. And here I'm just going to simply print out my name variable. Remember, this name is just a temporary variable that we're using to work with our current element in our list. If I go and run this, you'll see it prints out the 4 names that I had listed here. Okay. Notice that the other variables, data samples and info, we didn't worry about. We're not printing them out. We only deal with the list that we created. So this is nice because it allows us to get information from a lot of different sources. This could be user generated. We could maybe have a sensor data, which goes in and pulls in data, writes it to a file, and then we read that file in. There's a lot of different ways that we can get list data, and this gives us a lot of flexibility by being able to say the list as a variable instead of having to type it all in, because as a developer, we may not know what that information is. So let's look at how we can create a list very simply without data. All right. So for example, I can have my data samples and I could use the list function. The list function will take in some values and create a list for me. So for example, I could use another function we've already seen, like range, give it a value of 5. Now if I run this, you'll notice it prints out 0 through 4. Just as when we created and used the range when we pass it instead of data samples in our for loop. This allows me to have data that I can work with, and what's nice about a list is I can manipulate that data. That's a very important feature to a list, is the ability for me to manipulate that data and change it. We'll talk about how we're going to do that in just a little bit. There's other ways I can create data. So for example, I'm going to create here a list that has the value 1 in it. If I run this, you'll notice it just prints 1. There's nothing special about it. But I can also say star 10. Now if I do this, this is like multiplication. And if I run this now, you notice that it prints out 1 10 times. Okay, so it's a kind of an interesting little idea that it's got here. It allows me to repeat data very quickly and easily. If I come in here and say 1, 2, 3 times 10, and I run this, you notice it prints 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Look at that. 10 times it's repeating that process. So this allows me to take a simple pattern and repeat it multiple times very, very easily inside of Python. Most languages don't allow you to do that. And you might say, well, why is that? Well, in most programming languages, an array is statically sized. Now, that means that an array can change the values inside of the array. And you as a programmer can do that. You can have your user do that, etc. However, by being statically sized, you cannot change the size of your array. It's limited. In Python, our list, which, like I said, closest example to it is an array in other languages, our list is dynamically sized. And as a dynamic list, it can grow and shrink depending upon the commands that we give it and the data we provide it. So this is a perfect example of how we can show that the commands that we provide to Python allow our list to grow dynamically as the program is running. Let's show how we can access individual elements of our list. Here we have a simple list. Our data samples is values 3, 4, 5, and 6. But let's say I wanted to access a specific value. Maybe I want to print it out. Well, I could say print data samples. And if I said print data samples, you're going to notice something. You'll notice that when I say print data samples, it goes 3, 4, 5, 6. And you see the square brackets. It's all on one line. This is how Python prints an entire list for you. And the for loop allows us to see those individual elements. So one way that I can work with my list is as the whole list. Now, typically that's not what we need. Typically we want to work with an individual element. The list is just a nice container that groups them all together. Think about if I had to keep track of maybe a quiz score for an entire class. I might have 15, 20 students in a class. Trying to come up with 15 different variable names could be a real challenge. And if I wrote my program for when I had 15 students and then the next semester I have 20 students, then I have to go in and change my program. But by using a list, I can put grades and all my information is stored in that one place and it can grow and shrink. But I have to be able to access those individual elements so I can put those values in. So it's pretty simple. I'm going to take out the for loop because we don't need that right now. Let's say I wanted to print out the second element of my data samples. I would simply say data samples, square bracket, and then 2. And this is going to print out my element at index 2. So just real quick, think about our past examples in Python. Which element do you think is going to be displayed? Well, let me clear my screen in my terminal and then run this. And you'll notice that it was element with a value of 5. And so if you thought it was going to be 5, you are correct. Why? Well, remember, Python is a zero-based language. That means that the first element is at index 0. The second element is index 1, etc. All the way up to 1 minus the length of my entire list. Now you might think, well, why is that? Well, it has to do with how we store information inside the computer. And this goes back to the old days of C programming language, and this is how it used to do array math. And it was able to figure, okay, well, I know how many elements into my array I am, and I could do some real simple math because I knew the memory location at the starting point. Now, the reason for this goes all the way back to the C programming language in the early 1970s. They had something that they called array math, which allowed for them to very quickly and easily access memory for a specific element. Now, we don't have to know how that works, and we don't have to work with that type of information, luckily now. Computers are much faster, and they do this for us. Remember, the faster the computer, the more things we expect it to do for us. We just have to remember that because of the way that these things were done way back in the 1970s, yes, close to 50 years ago, we still follow through with some of those traditions and expectations. So here's how we display the element 2. Now what happens if I want to change that element? Well, that's very simple. I can say data samples, square bracket 2 equals, and give it a new value. In this case, maybe 9. I'm going to print out my data samples. This way we see the original value, and then we change the value, then we can see the new value. If I run this, you'll see it shows 5 and then 9. Remember, we only see it when we print, which is why we had to have that second print statement. So being able to access that information is very important to us. Let's look at some other things you might see. This one's a little bit interesting. I'm going to say -1. Now you might go, -1? How can you have an index of -1? 0 is your first element. You are absolutely correct. But with negative numbers, I can start at the end and work my way back. -1, if we run this, you're going to see shows the value of 6. It's my first element from the negative. Now I can't have a -0, which is what you might think, okay? So -1 is my very last element, in this case 6. -2 would be my next to last element, 5, and on that list can go. Now there's a lot of different functions that we can use. Some are external and some are internal to the list. Let's start by showing you an external function. And when you look at strings, you're going to see this very same function. It's called len. And I'm just going to say len for my data samples. And what len does is it gets the length. Now, a lot of times computer programmers, we love our abbreviations, and that's what len is. It's just an abbreviation of length. We don't want to write more than we have to. Some people say that we're lazy. We prefer to think of ourselves as efficient. Okay, so we wrote len. I'm going to come down here, clear my screen just to make it a little bit easier to see. And when I run my Python file, you'll notice it prints out 4. there are 4 elements inside of my list. Okay, so Len is very useful actually in a lot of different scenarios. Maybe I need to have a certain number of elements in a list in order to be considered valid data. I don't want to look for an average temperature if I only have 2 temperature values. I need to have maybe 10 to be considered to be relatively accurate and finding an average for things. I can have 1 or 2 values that just skew things badly. So I need to have a minimum number, and I can write that into my programming logic. Or maybe I need to look at, I only want the top 20 people when I'm looking at interviewing them. And so I've given them some sort of scoring system and I put them in. Okay. I don't want to look at all 200 people that apply for a job. I only have time to interview 20. And so I score them somehow and I'm only going to look at the top 20. And so I can use the Len to determine, hey, how many elements are in here and do I need to work with that some way? All right, so let's look at some examples as to how we can work with a list. Okay, so we've already seen how we can change existing values inside a list and how we can create a list. But what can we really do with it besides just printing out some information? Well, one of the things we need to do is be able to figure out how do we add new elements or remove elements from a list. We mentioned that lists in Python are dynamically sized, meaning that it can both grow and shrink based upon our needs. So let's see how we're going to do that. And a real simple example, since we know that there are 4 elements inside of our list, indexed 0 through 3, you might naturally think, well, I'll say index 4 equals 9. And if I run this, you're going to notice that we're going to get an error. The error is an index error, and unless we do a try except, we would get this error. So let's see how we can work around that. Well, I'm going to say data samples dot, and remember that Python, because it knows it's a list, is going to say, hey, here's some other methods that are available for you to use. Remember, a method is just a function that's part of this data class. And you'll notice the very first one that Visual Studio Code gives us is append. Now, Visual Studio Code often puts things that are most commonly used, favorited type of events, if you would, up at the top. And so we see append. And so I'm going to say append. And in this case, I'm going to give it a value of 9 because that's what we showed earlier. Now, if I go to run this, you notice that it prints out 5. So it has the 4 elements that we initially created it with, and then we append a 5th element. And so that allows us to access that information. It's a very easy way to work with that. I'm going to just delete those 2 lines of code just so we can work with this next section a little bit easier. Now we have the data samples.append, and append is always going to add it to the end of a list. But what happens if we want to put something in the middle? Well, I have data samples dot, and I have insert. So insert takes 2 parameters. The first one is where do we want to put this? The second one is going to be the value that we're inserting. Remember, we're using numbers here, but it could easily be a string or some other data type. So I'm going to say put it at index of 4 and a value of 7. Now if I print data samples, remember 9 got appended, so it's at the very end. And if I run this, you'll see that's 3, 4, 5, 6. At the 4th index, insert 7, and everything else gets pushed down. Okay, so that becomes really easy. Insert allows me to put things anywhere that I want. If I were to, for example, say, you know what, at index 0, I want to put 2, I can run that, and I essentially prepend or put at the very beginning the value 2. Once again, I am choosing to put these in order just so it's a little bit easier to see when you print them out. You, of course, do not have to have your values in order. So this, of course, leads to a question. What happens if I try to insert a value that's at an index that's beyond what my current values are. So let's just try to say, hey, I'm going to insert this at index 10. What's going to happen? I'm going to run. So notice that it did not generate an error. It put it at the end of my list. But notice that did not create any empty values that I'd have to go back and fill in. It just says, hey, I'm going to put at the end, make it the last one. We're not going to generate an error because we're just going to be a little more friendly to you. I'm going to clear out my terminal window, and I'm going to replace this with some data I have from another location. Here I have some songs. These are some famous songs. You might know them from the Beatles, and I'm inserting them. Now, the reason I'm doing this is just to show you that it also works with strings, not numbers. A lot of times we tend to get focused on something, go, oh, it works with numbers, doesn't work with other things. So let's just kind of see this in action. And you'll notice here that Hey Jude, Yesterday, and Here Comes the Sun are listed initially. I then put Help as the very first song, and then I insert into index 3, Come Together. Now, one important thing to notice about this as well is if you look at the first list, okay, Hey Jude, Yesterday, and Here Comes the Sun, you're going to notice there are 3 items. So Come Together got inserted based upon the list after Help got inserted, not from the initial list. So lists are very dynamic, and we have to be careful. We can't say, oh, this is what it started off as. We have to look at as to what's the current set of values for the elements of my list now. What's their position? How is that going to work? Now, you also might look at this and go, well, hey, this is nice. I like the fact that I've got this list, but it's not in a alphabetic order. Could I sort this? And the answer is, why, yes, you can. So all you have to do is say songs.sort, and this is a function that Python provides for us. It has a built-in way to sort very quickly. It does have an optional parameter, which is, do I want it to be reversed? We'll just show you what that looks like in just a second. So I'm going to real quickly say print songs. Remove that one, we don't need it. I'm going to run this. You notice it says, Hey Jude, Yesterday, Here Comes the Sun, and then we get added in Help and Come Together. But now after we sort, it starts off with Come Together, Help, Here Comes the Sun, Hey Jude, and finally, Yesterday. So I'm going to specify reverse equals, and then I'm going to specify true. So if I do that and run it, notice that now my first one is Yesterday, then Hey Jude, then Here Comes the Sun. It sorts it in reverse or descending order. So by default, it's going to be ascending, but it can also be in descending order. I'm going to clear this out real quick. Put in data points, which is going to be a new value. I'm going to do 3, 6, 1, 7, 9. And say data points dot sort. We'll sort in ascending order, and we'll print data points. Notice that this works and now prints in ascending order numbers just as it did strings. If inside my sort method I said reverse equals true, then it would sort in descending order. So it would show 9, 7, 6, 3, 1. So my sort works for both numeric data and string data. But I do want to show you something real quick. Notice I'm going to create a 5, but it's a string that's 5. Okay? Very important. Notice that it's a string. If I go to run this, you're going to get an error. Python says, hey, if I'm dealing with all strings, I can do this. If I'm dealing with all numbers, I can do this. But if you mix your data types, it cannot sort it. It does not know how to replace this. Even though it's a 5, It's a string that is 5. And so it doesn't know, should I think about it as an integer 5? Should I think about it as the ASCII code for the character 5? Should I think about it as something else? It doesn't know. And so you cannot mix data types when you want to sort a list. That's a very important thing to keep in mind. I want to show you what happens even on something so simple like this. Now, there is an interesting thing that you can do that some people think of when they look at sorting. They think it's an extension of it. It's not really. But I can reverse a list. So I'm going to use the reverse method. Now, some people think that reverse is tied to my sort. It's not. Let's see what happens here. Notice that it just puts my list in the opposite order. So this is something that, like I said, some people think it has to do with sorting. It does not, which is why you can use mixed data types, because it's not having to sort. It's just going to reverse my list. Now, I can sort and then reverse. I can do the reverse sort. I can just reverse an unsorted list, and that's what I did here. You don't always need to use this feature, but it is nice to know about for when you might need to use it. Let's look at some other things that you might have. So I have two lists here, list 1 and list 2. Okay, very simple. You can see at list 1 is a set of even numbers, list 2 is a set of odd numbers. Now, why would I want that? Well, let's show you what we can do with this. Let's say list 3 is going to be list 1 plus list 2. And now I'm going to print list 3. So notice that it takes my list 1 and then appends all of list 2 to it. Now, this is often going to give me a collection of unsorted information, even if my previous 2 lists, like you see here, was sorted. So we will often take, and before we print it out, sort that list. Now, if we go and run this, you'll see that it prints it now in a sorted fashion. So this is starting to combine some of the things that we can do with this. What's interesting is I don't have to create a brand new list. So I'm going to specify list 1 plus equals list 2. I print list 1 now, and I'm just going to do a CLS real quick on my terminal to make it a little bit easier to read. I run this. Notice that it automatically adds it, appends it, if you would, to the end of my existing list. So I can create a new list from this, or I can take an existing list and merge it into my other existing list. So this creates a lot of really interesting opportunities for me for how I want to use data. Especially if, let's say, I had a series of data files I was reading in. So this is something similar to what I've done before, where I've brought in multiple files, and I might have 3, 4, 5 files or more. Maybe there are files from different office locations or store locations, and I need to bring all that data in and work on it all at one time. Well, this was a really easy way to do something like that. This is not the only way to do that, of course, but this is one way that we could work on it. And so here's an example of what we've done. I've also done different data files because we want to look at data over maybe a week's period of time. I brought in data from different files because we had it from different sensors and different logs that we brought in. There's a lot of different ways that we can use something like this very easily. Now, sometimes we want to look to say, hey, does a data value exist? And if so, what's the index of it? Okay. Now, I could maybe write like a for loop and say, okay, for list 1, and then have a value say if element equals 7, and then try to break out of the loop and say, oh, I found it. It was that's a lot of work. Okay. So let's look at an easier way of doing this. I'm going to print list1 dot index, and I'm going to pass in a value that I'm searching for. So in this case, let's say 3. Use a clear screen on my terminal just to make it a little bit easier to read. I run and it says, oh, it's at index 5. Okay, that's nice. It lets me find my first element. By the way, it finds the first element if you have two elements with the same value. It's going to find the first one, and it gives us the index. I can then say list1 square brackets 5 equals, and then maybe give it a new value. What happens, though, if it's a value that doesn't exist? Well, I could come in here and say 13. If I run that, you're going to notice it's going to give an error, and it creates this exception error. So I would need to use a try except block in order to capture that to make sure we don't have that issue. Another way of handling this is slightly different. You say if 13 in list1. Okay, so this in command is a command that we can use with list that's going to look inside here and see, hey, is this an element of this bigger piece? We found it. Else we didn't find it. Do a clear screen, run, we didn't find it. If I have 3, we found it. Okay, so this makes it really easy. Now, it does not tell us the index. So if we wanted to get that, we would then have to say print it's at index run that. We found it. It's at index 5. So notice I had to combine two things. It makes sure that the element exists, and then it checks to find what the index is. Does this work? Most of the time, yes, it does. Is it a perfect solution? By no means. It's just a matter of what are you trying to do. Okay, so here's just a real simple example where you can kind of work with something like that. It creates an interesting way. Do I just need to know that it's in my list? If so, just use the in. That's a whole lot easier. If you need to know a specific location, then you have to determine, do I want to do an if statement like this, or do I want to use a try except block? Which is easier for you? The good news is you have multiple ways of doing it. And if 2 ways are equally effective, then it really becomes a programmer's choice. So just kind of keep that in mind. What's nice is we can use this in function to also test for other methods just to be a little bit safer. Let's say I come here and I want to remove element 3. Well, I can say list1.remove and then specify 3. And use CLS on my terminal just to make it a little bit easier. We know that 3's in there. We can see it. If I run, notice it says we didn't find it. It found it before because it existed before. When we remove it, it's deleted out. It no longer exists. Okay, that makes sense. What happens if I try and remove element 13? Element 13 does not exist. So if I run this, notice that I get a value error. Once again, I have to think about how am I going to solve this problem? Try except, or maybe checking and putting it in an if block. If 13 in list1, list1.remove 13. So this in command, even though it's not built in as part of a list, it has a lot of functional uses in list and ways that we can do it. Because several of our methods that come with lists and are designed as part of a list will generate some errors for us. The remove and the index are just 2 examples of those. So always kind of keep these in mind, and learning how we can kind of put different elements together really makes it faster and easier for us to work with. Now let's look at some ways that you can expect to work with lists, some potential issues you might run into, and some solutions on how to fix it. So let's start off though first looking at primitive data and say x equals 5, y equals x. And if I print x comma y, when we run this, you're going to see they're both 5. Okay, that makes sense. And if I come in later on and I say, you know what, x equals 10, and I have print xy, you're going to notice that it's 10 and 5. Okay, this is known as a copy. We copied the value from the right to the left. So we set 5 equal to x. Then we said y was equal to x, which means that it was equal to 5. The fact that we changed x later on didn't change what that initial value was. You could think of it like a snapshot. So let's make just a quick little change and say that x is a list with a single value of 5. We're going to see how this is going to change things. And so I'm going to say y equals x, just like I did before. But then I'm going to say x at element 0 is equal to 10. Let's see what happens here. And I'm going to clear the terminal screen just to make it a little bit easier to see. And notice that they both show as 10. Okay? So what happened in computer science parlance, we call this a shallow copy or a copy by reference. And that means is that when we deal with a list, because a list is a complex data type, and most languages do this, if I try to copy the value of a complex data type, it says, well, wait a second, there could be a lot of data over here. I don't realize, and I don't make any judgments to say what a lot is. It could be 1,000 elements, it could be 100,000 elements. Duplicating it, though, could be a real challenge. And so no matter how many elements it is, even if it's only one, like you see here, I'm going to instead say, you know what? My variable points to a location in memory. I'm going to have this variable point to the same location. So no matter who changes it, both of these values get updated. Now, this is done for efficiency, and it makes it much faster when we create or duplicate these values. But it can lead to problems like this. So how do I make sure that I get my own separate list? Well, a simple solution we've already kind of seen is we're going to say, well, I'm going to concatenate my X list with another list, but I don't want to change it. So I'm going to create an empty list and add X to it. If I do this and run it, you're going to notice that it's 10 and then it's the original 5. And that's because it's a brand new list. We forced it to duplicate it, not point by reference. In computer science parlance, we call this a deep copy. Okay, so this is a very important thing. We have shallow copies by default, but we have tricks to make a deep copy. That allows them to create two separate lists, so a change here doesn't affect this one. And likewise, a change over here doesn't affect our original. Very important to keep in mind. Now, in some cases, we don't care, and that's okay too. I'm going to erase that and replace it with another set of values. And I just have here some numbers. And what would happen if I wanted to get the total of that list of numbers? So let's see how we're going to work with this. First, I'm going to create a variable called total. And I'm going to set it equal to 0. Okay, you'll see why in just a second. We know that we can use a for loop to loop through our list of data. So I'm going to say for num in numbers. So remember, numbers being plural, we named it plural just to make it easier for us to work with. It's a whole list of values. Then I'm going to say total plus equals my current element, my current number. As long as my list of numbers is just numbers, this is going to work for me. Obviously, if I had mixed data, strings and numbers or Boolean and numbers, it would cause an issue. Or if I had non-numeric data, it might cause a different type of issue. But this works for numbers, and that's what we care about here. Now, I'm going to come after my for loop. I'm going to unindent, so I'm on the same level as my for. I'm going to print total. do a CLS in my terminal window. And when I run, you'll notice that it gives me 48. That is, it gave me all of the values summed up. Okay, so this became a real easy way to work with that. So starting to think about how we're going to use list often depends upon what type of data we're storing. If I have, for example, a list of sales receipts for a day or for maybe a week, and I want to add up all those sales receipts so I can then put it into my accounting software, this becomes an important thing. If I want to keep track of how many reservations there were and I had reservations put into a list, this would be a way I could do it. I could start keeping track of who are my customers that come back to me regularly and show up with reservations. And then maybe I could do some sort of rewards program for them. So the programs we write are all about what types of questions are we trying to answer or problems are we trying to solve. And if you go back to our very first module, we talk about what is computer science. We said that's really what computer science is about. It's about solving problems, and how do we go about solving problems and do it in an efficient and repeatable manner. So let's look at some other things that we'll typically do. For example, how do I pass this to a function? So I'm going to create a new function. Def get total. I'm going to have values. Okay, you might say, well, what's values? Well, values is going to be my list. And so I'm going to say total equals 0 for num in values. Total plus equals num. Okay, so this should look kind of familiar to what we did up above on line 8, 9, and 10. Okay, the biggest difference is we are going to return a value. So I'm going to return total. And then I don't need 9 and 10 because I'm going to do that inside my function. So I'm going to say total equals get total, and then I'm going to pass in numbers. Now, notice that in my function, my parameter is values, but when I pass it in, it's a variable called numbers. Our parameter names do not have to equal our initial value names. Okay, very important to remember, just like before, this is making a shallow copy. Remember that from before. So we want to make sure we never change values unless that's our intention. Okay, because they will go back to the original set. But here I'm getting my value for total, and then I'm going to print it out. And if I go and run this again, you'll notice I get the exact same value. You might think, well, this seems like a little bit more work because you had to create a new function, and you're right, but what happens if I had an accounting piece of software and I was looking at my sales receipts and I was going through every one of them and I needed to count up how many of each individual item was listed, or I want to count how many items on average was on each sales receipt, and I had thousands of sales receipts. I might have to go through this in a repeating fashion, and so it makes it easier. So remember, functions are like little mini programs, and I want to write them whenever I might have to go out and do something over and over and over again. And this is a good example. I might have to do this in different places. Getting a total, getting a running total, sometimes people call it, is a common thing that people have to do in software development. So these are just a couple of simple ways that you can see us starting to use list. And how you choose to use list and what types of data you work with and what types of problems you solve is often dependent upon what they call your domain or your area of knowledge that you're working in. If you're working as a chemist and you're looking at sample data from experiments, you're going to see something entirely different than someone who is writing some back-end software to run an accounting for a website application. or who might be doing some bookkeeping and scorekeeping for a league of local sports team or set of teams, if you would. And so we want to keep this kind of vague in these examples so that no matter where you're going to use it, you can see this being applicable. So just kind of keep that in mind. So I'm going to clear out my previous example, but I'm going to leave my list of numbers. And I want to go back and just make sure you understand and make sure you see a couple of quick and important things about your list. We've talked about it, how you can change the value. So if I know an index, I can go in and change that value of the list member. We've mentioned how they're dynamically sized, which means that you can add elements to and remove elements from a list. And we saw how to do that with the insert and append methods as well as the remove method. So what else could we be looking at? Well, what happens if you didn't want the values to change? You might go, why would I want that? Well, if I had a data structure, a sequence, because it's a collection of elements in Python parlance, that was not likely to change, then it would be a little bit more efficient and a little bit faster. And it would almost be identical to a list. Python calls this a tuple. So if you think about things that are not going to change when a program's running, you might have things like, for example, a list of presidents or other elected officials. Yes, they do change. In the United States, presidents will change at least every 8 years, maybe 4 years, and in some cases less than that. But due to the rules in the Constitution, our president has to change at least once every 8 years when an election comes up and they're no longer able to run for re-election. Well, what's the odds that the list of presidents is going to change while your program is running? It only happens once every 8 years. Okay, so do you really need to update that? And are you going to be updating it when someone is running the program? Probably not. So that's a good example where you might want to use a tuple. A tuple is almost identical to a list, except it's immutable. And we talked about immutable before when we talked about strings. It's unable to change. We cannot change its values. We cannot add elements to it. We cannot remove elements to it. But it takes up less memory and is faster because it doesn't change. So if I want to convert a list into a tuple, I can say tnumbers, and we're just going to call it that for being tuple numbers, equals tuple. And then I'm going to pass in my list. And if I print numbers, and then I print tnumbers, so if we print numbers and then we print tnumbers, we're going to see the difference. If you look at our terminal output, you'll notice we have square brackets for our list and parentheses for our tuple. Outside of that, there is no difference. So if I want to come in here and say print numbers index 3, and I want to do a tnumbers, you'll notice that it gives me the exact same info. So you might therefore ask, well, okay, tuples are great for holding information, but I can't change any of the values in it. I can't add to it. I can't remove from it. Is it still valuable? Yes. Yes, it is. You just need to think about, is it an appropriate place to use it? Maybe you have a list of values that are not going to change. Prices, for example. Your prices are not going to change, at least not very often. You can load them up, store it in a tuple. It's very fast and efficient. Let's take a look at a couple other things. Now, the other question that people sometimes ask is, are there properties and methods that I can use with my tuple? Well, there are a few. I can use a count, and a count's going to count how many times I can find a particular element inside my tuple. I have an index, which returns the first index of the value that I searched for. Remember, this is also under list. There are a few other things in here that are more built in that we don't have direct access to. They're hidden. The index and accounts are really the two things you're going to see most often. You can print len. Remember, len gets the length, and it gets the length of strings, it gets the length of list, it gets the length of tuples. And so if I do a CLS down here, and I run it, you can see I get the length. You can also use the end keyword like we used with list. So how you use a list and a tuple are very, very similar. You just have to remember that a tuple is immutable. It cannot be changed. If you're running a program that's okay, you would probably be better to use a tuple. In reality, I see more people using list even when a tuple would work, partially for consistency so they don't make mistakes, and partially because the thought process is, well, computers are so fast now, it being just a little bit slower probably isn't going to hurt me. And in reality, this is probably true as well. So don't feel like you have to use a tuple. You don't, but it is a tool that Python provides for you in case you need the utmost performance, or you're just going to use it because you like using the appropriate tool for the appropriate job.